Okay, so this is the review for the final. We're going to start with question 1, 2, and 3 on this video, which is the introduction and kind of the meat of the exponential unit that we started with the second semester with. So question 1, a petechial rash grows exponentially with a growth factor of 1/6 each hour. By what growth factor does the population change each half hour? So the one thing we need to remember is that it's not linear. So we're not just dividing this by 2. That would be linear, but because this is exponential, instead of dividing by 2, we're going to take the square root of 2. And so that's why when it says write a radical is that we're using the square root. So this we have to pay really close attention to the units. This says each hour, and this says each half an hour. So that's why there's 2 half hours in an hour. So we're going to take the 1/16 and we're going to square root it. If it was like a third of an hour, then we would cube root it. If it was a fourth of an hour, we would do the fourth root of it. And then we can also do the square root of 1/16, and we can check that in our calculator to see if that works. The square root of 1/16, we get 0.25, and then we can make that a fraction. So 1/4. Right, so this is really equal to 1/4. And we can also think about it as we do the square root of 1 is 1, and the square root of 16 is 4. All right, and then when we want to write it as an exponential fraction, so that means we still have that 1/16 as our growth factor, and the same thing that we can do for a square root, we can also write it as an exponent of 1/2. So 1/16 to the 1/2 power. So just remember, exponential means that we don't divide it by 2 like we would think for linear. We need to square root it or cube root it or fourth root it, whatever we're doing to it. So the doctor treated the petechial rash with 80 cc's of medicine. If the medicine had a half-life of 2.4 hours, how much medicine is left after 2.4 hours? Well, if it's getting cut in half every 2.4 hours and it's starting with 80, then 2.4 hours later, it's going to get cut in half. So that means there will be 40 left. That one we don't even need a calculator for. The other two, I think it's easier to do with the equation. So I'm going to skip to writing the equation part. And I don't have my mouse here, so I'm going to type it in. So when I go to type it in, there we go. So it's f of h, because that's what they're telling us. So the function based off of the hour. So how much medicine is left based off of the hour. So we do how much it started with. So they started with 80 cc's of medicine. The growth rate, which the growth factor, which is a half-life. So that's 1/2, or you can do 0.2 or 0.5, however you want to do it, half-life. And then we need our exponent, and our exponent is normally 1, but because it's saying it's happening every 1.24 hours, then I'm going to put the h, and I'm going to do that over 2.4. So that tells me that when I do 1 hour, it's not going to get a half-life all the way because I need 2.4 hours to make it a complete half-life. So then for this 1.2, I plug 1.2 in for that h, and then for this one, I plug 1 in for the h, and it will tell me. So that's when I just use my calculator, 80 times, and I'm just going to do 0.5 because that's the same thing. It's just faster. Remember, it needs to be in parentheses. So this will be the 1 hour one. Sorry, I'm kind of doing them out of order. So 59.932, 59 point, oops, this is terrible. Sorry. I'm just gonna type it in. 59.932, and then don't forget the units, cc's for that one. And then the 1.2, I'm gonna just type in the same thing, except make it 1.2 divided by 2.4 as my hours, and I get 56.569 cc's. I'll write that here. 50.569 cc's. All right, so don't forget the unit like I did here, cc's. Sorry. Okay, and then the question number 3. This is actually the one that we should have started with. So here's our model, and they're asking us what it is. They're talking about rhinosaurs, and how many they have in their population based off of the weeks. So when we first started, before it started growing anywhere, it said it was 2, but they told us it was in thousands, so it's going to be 2,000. And our unit is rhinosaurs or rhinos. Then 1 week later, what is it going to be? Well, we're going to put 1 in for that W. So I'm gonna go to my calculator, 2 times 1.15, and now I'm gonna put a 1 for that 1 week. I'm gonna get 2.3, but that really means 2.3 thousand. So that's 23,000. So 23,000 rhinos. Then what's the growth factor per week? Well, this is per week. That's what the W stands for. So it's 1.15. Then what's the growth factor per day? So I'm going to take that 1.15, and that's per week. So when I want to find per day, I'm just going to take that and make a new exponent that instead of saying one would mean week, I need 1/7 of that week because there's 7 days in a week. So then that's what I would put in my calculator is 1.15 to the 1/7. Just don't forget to put it in parentheses when we put it in the calculator. So 1.020. So my answer for that one is 1.020. And then the same thing with the next one, but now it's asking me per month. So that means that I'm actually going to have more. This is going to compound more often. And so if there's about 4 weeks in a month, I'm going to have it to the 4th. So there's 4 weeks. So this is going to compound. It's going to grow exponentially 4 times. So 1.15 to the 4th and 1.749. That will be my answer for that 1.749. All right, that's it for 1, 2, 3.